Hello everyone, myself Swastik Patsalkar and I am an a quantum computing enthusiast. And the topic that I am going to discuss today is quantum in high performance computing. So let's get started. High performance computing is a technique or methodology through which we can execute a complex task requiring higher memory consumption, processing power in a minimal amount of time. This can also be achieved through the term called parallel computing, where there are two or more multiple threads executing simultaneously to solve a problem and give an appropriate result. Next, the role of HPC in quantum computing. An ideal quantum algorithm is hybrid in nature, that is, both quantum and classical. The hybrid quantum classical algorithm that we want to implement rely on Ansat's creation that harness the power of quantum mechanics. The qubits are involved in this process, which can be both 1 and 0 at the same time or the state between them, which can be called as a superposition state. Interference is the pattern that can be inspired from quantum mechanics and is well used in achieving the final output. And entanglement is to associate the what do you say the parts of the problem into a given algorithm. Next, the quantum gates rely on matrices. As you can see into the picture given, uh, a quantum state is well shaped into a matrices to perform the operation and achieve the results. The real time QPUs are fragile. This is so because today's fault tolerant quantum computers are NISQ, means they are not fully fault tolerant, but they can solve some of the problems, but not a problem through which we can achieve a quantum advantage. So, to push forward the quantum advantage into our algorithm, GPUs can accelerate the computation and process the higher dimensional matrices, vector spaces, etc. Here are some laws in HPC which are basic laws. The Moore's law talks about doubling of transistors yearly. This is a very primitive law which has been since 1960s when the era of computing or transistors started. Amdahl's law. This is the law which says that uh, the power of a parallel processing is limited by the non-parallel or sequential processes. It can be given into the equation format below. Next is the Gustafson's law, which states that efficiency of parallel processes can be well defined if we know the problem size, how it increases gradually, and it is also quite essential in knowing how our system is going to be efficient. Here, the S stands for speed up, N stands for number of cores or processors, P stands for parallel process in algorithm. Universe platform. Universe is a high performance computing platform that unites many of the uh, libraries from Qiskit, Circ, QACC, SuperStack from companies like IBM, Google, Microsoft, etc. And also, this is a platform in developing stage, but then also it provides a very good amount of simulators, CPUs, GPUs, through which we can run our jobs and test our created quantum algorithm and the quantum circuits. For every job to run, a credit is deducted. Next, the provide it also provides algorithms and interface to visualize and develop algorithms with complexity controls. We can also see how the state vectors give the outputs and the probability histogram and all. Algorithms in quantum are fundamental algorithms such as Dutch-Josa algorithm, Bernstein-Vazirani algorithm, quantum Vito protocol, Simon's algorithm, so Shor's algorithm, quantum Fourier transform algorithm, Grover's algorithm. These algorithms are well discussed into the CDAC Universe course, for which the description is given into this video. Here is an example of the algorithm, which is Dutch-Josa algorithm, which I have generated through this platform of 10 qubits, and the results are also much clearer. The job was run on SuperStack hardware QPU, having the backend as IBM Q Brisbane QPU. We can increase the number of qubit and test our algorithm quite efficiently, though the quantum computers are limited, but we can design our algorithm and have a quick glimpse of it. Here is the hypothesis that I have got an intuition of. On the y-axis is the software requirement, and on the x-axis is the hardware requirement. We can say that today's quantum computers rely on CPUs, GPUs, because these are the type 0 quantum computers, which needs the computation of large probability and density matrices, and also the fault tolerant computers are not that capable. So by this cycle of error correction, finding feasible problem and testing, we can really develop our quantum inspired algorithm. So there is one annealing stage or the stability stage through which we can simulate any material or develop a drug. Depending on the complexity or the type of problem, which increases the hardware requirements substantially. We know that software is always independent of hardware, because software is what does not degrade gradually compared to the hardware. So from level 0, 1 to level 3 up to level n, there will be a cycle of or agile like cycle of finding a feasible problem, then testing it, and again error correct the type of system or the, we can say, quantum system that we have developed, and this will lead to in future various type of quantum computers that could solve our problem. Applications of quantum computers are well diverse. It can be applied in drug discovery, material design, simulate and estimate NP hard or NP complete problems. We can also try and test phenomenal ideas if we know the basis of advanced mathematics and algorithm design. We can also know or calculate how we can create Dyson sphere and other science fiction type of innovation that we are not sure, but we can actually hopefully dream about them through a quantum computer. There is a great saying from a scientist named Thomas Alva Edison. He had told that I have not failed 10,000 times, I have succeeded in proving that those 10,000 ways will not work. He had tried many of the alloys in proportion of the metals to create a filament through which he can light a bulb and sustain it for a longer time. Similarly, we cannot say that a flame of light or the fire in the flame cannot be used to develop a quantum computers, but a substantial uh, occupancy or applying of knowledge can melt down a problem and finding a solution that could create a fault tolerant computer. So likewise we can utilize today's CPUs, GPUs and other hardwares to create a material which could be more fault tolerant, and then substantially develop quantum inspired algorithms and test them rigorously in a brute force way that could create a quantum breakthrough, and that breakthrough can then be utilized a more higher advanced type of quantum computer. I know it is not, it might not be seem as practical, or it is just a hypothesis, but there is no end of creativity, because being a human we always strive to show our competency and our increasing consciousness levels to gain the self actualization. So while ending this session, I want to say is that there is no end to human creativity, and hence we can keep on proving ourselves by tackling the upcoming problems. If you like this video, kindly share and subscribe to the channel. Till then, thank you, have a nice day, and bye bye.